we don't get to the hands-on part for a few slides in. I apologize for you. This is going to be a few review slides from this morning, but so I'm Jeremy Fischer. I'm the Senior Technical Advisor for Jetstream. Were you at my thing a month ago?
No.
Okay. All right. You look familiar. All right. So we're going to talk about Jetstream a little bit today, and then we're going to do some hands-on with the API. So I'm going to start in. A little about Jetstream. So we are part of the EXCEED program. It's part of the Extreme Digital's NSF-funded project to bring cyber infrastructure to the entire United States. We focus on ease of use, broad accessibility. It's basically a means to provide, especially with the API side, to make your own programmable cyber infrastructure. Basically to be able to build what you need to get your science done. With a big focus on reproducibility and then publishing through a DOI system. We won't be talking about that much today, but I just want to give an overview before we jump into things. So the who, so Jetstream is from people needing modest compute resources, 1 to 44 cores as a VM, people needing to have very custom workflows, to have absolute control over their environment, people doing science gateway development, and then people that are teaching that want to have the ability to create a resource for their coursework that students can watch again and again and again. So what we aren't, we are not traditional HPC. So if you need thousands of cores, it's not going to be necessarily the resource for you. We don't have a shared file system, so if you're looking for a giant Lustre file system, it's not going to be there. You have to think in more of a cloudy way of having volumes and having a local file system to your VM. Interconnect fabrics, we're not a high-speed, we're not an HPC resource, so we're not high performance in the sense of being the fastest at everything. What we are is a very solid, very usable resource for doing virtual machine services. They're not GPUs today, something we're working on. And then what I like to say is we're not Amazon, Azure, or Google. And that's basically looking at, we provide a lot of the same core services, but we are a system that is powered by researchers, for researchers, by people that know how to support researchers. So our goal in life is we support researchers getting science and science education done. So the way of the cloud. So hi there. So thinking about things as they used to be, the old way is the machines were very expensive. The software you expected to fail. You expected the hardware to last pretty much forever. Today, the hardware is commodity. If it fails, you throw it away. You just get a new one. You put all the intelligence into the software, so you make it a very robust computing environment based on software. But the best part is, my favorite slide, thinking about VMs, is cattle, not pets. So you make it so that you can launch a VM over and over and over. You create your workflow and save it. And that way, if you lose one, you just launch another and continue your work. If you just have one that you've customized heavily and it goes away, well, you're going to cry and you're going to have to do your research over again and things are bad. But if you've made it so you can reproduce it again and again and again, you get around the problem of having everything dependent on just one. You just launch another one if you need it. So a little about our overview. We have 2 production clouds, one at Indiana University in Bloomington and one at Texas Austin. We have a production cloud in University of Arizona, which is strictly for development by the Jetstream team. We're interconnected through internet too, so we have nice fast interconnects everywhere. And then looking at our actual platform overview. So these are actually pretty representative of what the racks look like. So IU has a set, TAC has a set. OpenStack is what I like to call our cloud computing, or cloud operating system. It's a virtualization manager, basically, but it sits on top of the operating system and allows us to control the virtualization aspects of Jetstream. And then Ceph is our storage backend. And sitting on top of that are Atmosphere services, which are the GUI front end. And we're going to look at the GUI front end in some slides, but we're not actually using it today. What we're going to talk about today are people coming in this way through the OpenStack API. So that's actually what we're going to do today. Looking at hardware instances and the flavors, so you can see the different sizes of the instances, again from 1 to 44 cores, and then these are just larger storage instances. You can see the amount of CPUs and the amount of RAM that go with each. So this gives you a kind of idea of what you can use on Jetstream. And then again, we're going to look at this is the interface we're not going to use today. So when you log in through the GUI, this is what you would see is the nice GUI interface with the dashboard. It lets you launch VMs, it lets you see what you're using. You can see the image catalog, which we're going to look at from a very different point of view today. And then launching. So you see the GUI environment of where you fill in the things you need and you press the launch button and away you go. And we're going to approach that again from the programmatic side. So we're going to look at it from the CLI, from logging in and doing things with the command line. And then again, once you have an active instance running, this is what you would see in the GUI. And again, we're going to see this from the more fun side, I think. So Jetstream is a gateway developer. Are you all familiar with science gateways as a concept? No. Okay. So science gateways are basically a means of having a front end, which is typically through a web hosting, where the developer has constructed very specific workflows. So say for we have a computational chemistry gateway that they have NAMD running in the back end to do molecular dynamics. You submit, basically they set up certain parameters for doing a run. You give it your data set, tell it what you want to do with it, and then you submit it. And what it does in the background is it either runs it on the system there or farms it out to an HPC system, runs it, returns it back to the user. So the idea is lowering the barriers to science by doing science gateways like that. So people that are doing this sort of development would use Jetstream in a way of from the API side, so that they could have an always up, always on service for people to use like this. It gives them programmatic access. What you don't get with the GUI side is you get a reserved IP address from the command line side. So if you want to have a service that's dependent on a URL, you've got to be on this side. And then you can do true elastic computing things. So since we have two clouds, you can program, we set it so you can balance between the two. If you have a heartbeat monitor between the two and one goes down, you can have it take over for it. There's a lot of possibilities with what you can do this way. So the basics that we provide, we give you some base images to start from. That said, on the API side, you can bring in most any image you want as long as it will run Cloud Init, which most Linuxes will. I hesitate to talk about Windows because you can do it, it's just very painful. But you have that ability to bring in your images there to work with. We give you a basic network space, and when I say some DIY required, we're going to cover what that DIY is today. We're actually going to walk through the steps of constructing the network and hooking it all up so you can kind of see it from end to end. We give you an IP pool to work from, so again, that public IP that you can work with. And then we give you an isolated project space for your team on two different clouds. So everybody on your team can see all of the other instances and work with them as well. And then, like I said, a blank canvas to some degree. You can install almost anything you want. You can bring your own licenses. You can kind of build your ecosystem the way you need it to be. A little bit about storage. So the VMs all have some amount of storage. Anywhere from 8 gig to 60 gig, depending on the size of your instance. And that's all defined in the flavors. We'll look at those a little bit, and then that's all in the wiki as well. But you think about the storage that's built into the VM is ephemeral. So that VM gets destroyed, you delete it, it's gone. It's just gone. You can't get it back, there's no getting it back. So we tell people, think about the storage of a VM as ephemeral. You don't want to keep anything of real value there for any length of time. It's fine as you're working. But if you have results for things that you're working on, you want to keep them on a volume. Volumes are more persistent. They're erasure coded for data to recovery. Basically, what that means in real world talk is we can lose an entire tray of disks. We can lose one entire server's worth of disks, and we're still up and running with no data loss. So that's why volumes are good. It's very well protected. And again, valuable data should be on volumes. And I say backed up elsewhere. We do not back up your stuff. There's no way to, because VMs come and go. So if you have important data, always copy it offsite. Always copy it offsite. Can't say that enough. We haven't lost anybody's data yet, but we don't want anybody to be the first test case. So some of the possibilities. You can do true elastic computing. You can use things like OpenStack Heat to script building up a whole bunch of servers or a cluster all at once. You can use OpenStack Magnum, which is container orchestration engine, so you can spin up a Docker Swarm or Kubernetes natively in Jetstream. You can build your own things. We have a lot of projects right now that are building virtual clusters. Again, most of them are gateways, so what they're doing is, instead of farming out to an HPC resource immediately, they'll build 2 or 3 nodes that are on-demand resources that they need, say 120 cores right now. So it'll pop them up as needed, do the processing, and then it'll spin them back down. So that's some of the things you can do about that. We're also going to be, that says PERC 17, but it's actually PERC 18. We're doing a tutorial on that in another conference soon.
Is anybody here from our Common Keys group? Are you guys from ARTS? Oh, okay, good. I talked to them earlier this week. I just wanted to make sure. So they're looking at possibly using a weather modeling from NOAA. Is that correct? And having it run on here, and I think maybe I mentioned it in the last session, and then display the data on a website for the
very much a Science Gateway model.
Okay, so that's what I thought. So glad to see you guys there.
Excellent. Well, good. Science Gateways. Jane's also going to be bringing in the Science Gateway folks at some point. I don't know when the timeline is.
Hopefully early next month.
You should definitely be here for that.
Yeah,
that sort of development will, for what she was talking about, or at least if I'm understanding correctly, will be valuable resources for you.
Yeah, and I'll arrange with Dr. Helmicky to have a session with you guys if it's something that you think is going to be useful. Thank you.
So with 2 clouds, there's also a little bit of fault tolerance. Now you have to make that work for you. There's no automatic failover of anything, but there's the possibilities there. So if you do a little architecting, a little planning, you can make it such that you can fail over. You can maximize your quotas, basically, of having things on both clouds. So there's definite possibilities there. So for big data, and everybody's notion of big data is very, very different. We tend to think of big data in terms of Jetstream. If you're going to host more than 20 terabytes, if you need, basically 30, 40, 50 more terabytes than that, we want to get you working on a different resource in conjunction with Jetstream. So Rancor is another Exceed resource that has a lot of storage available. Physically at IU, it is 4 feet away. So they are cross-wired into each other. And basically, we've got a cooperation agreement with the Wrangler admin so that if somebody wants to serve data off of Wrangler, we build a virtual private network over to Jetstream, and then you can mount it from your VM. So you have it available just like a normal NFS connection. NFS connection, and it's available to you easily and quickly, and it's fast. So that's, when we talk about big data, that's our sort of idea there. If you're looking at data in terms of a terabyte or a couple of terabytes, we can do that natively on Jetstream. So this is just for fun. It's the happy cluster, angry cluster. They're air-cooled doors. So when things are happy, everything is blue, and when things are not so happy, they turn red. And then the more important thing, where can I get help? And I will give you, actually, I've got a couple of our cards up here, which have the wiki address on them. And these slides are also available as well. That has our help address and information on it. And I think I gave you one this morning. Yes, okay. I thought I did. So that way you don't have to worry about writing anything down. But the wiki is the best place to go for documentation. Failing that, the email will get to a team of folks that can answer questions. And our NASCAR slide. So these are all of our partners. Indiana University and TAC, of course, being the main partners, with Arizona providing the atmosphere interface. And before we move on, questions? Anyone? There's no quiz.
I have one question.
Sure.
You're running the clusters in different universities, right?
Right.
So will that, like, if at all we go for Jetstream and try accessing the VM using through UC network, and we'll be logging into a different university's firewall, right? So will that be a problem between the networks?
No. So at IU, Jetstream sits in what we call our research DMZ. So there's no firewalling there. The only things that are several countries that are restricted that are on the ITAR agreement thing, but coming from UC to Jetstream at IU or going to Jetstream at TAC, not a problem. Yeah, completely open. We're a research system. We want to make it easy, not put up barriers. Yes?
Is Ukraine one of the countries that's allowed?
No.
I
No.
I don't, you think it is? It's not in the, it's not in the ITAR.
If it's not in the ITAR list, it's allowed. So I think Ukraine is allowed.
Not currently.
Yeah.
Yeah.
I can look that up here in a moment and tell you definitively what's blocked. There are only a handful, and I don't remember seeing Ukraine in there.
No.
But I'll double check that for you.
Yeah.
Mhm. Other questions? Comments? Thoughts? All right. So moving onward a little bit, we're going to jump into talking about actually getting on and using the system, but there are a couple things that we want to talk about first and what they mean. So I'm going to throw a lot of terms at you at first. The first is image. So that's basically the instance on a disk. So it's a file on a disk. It has the operating system fully contained, and you boot that and you create an instance. So an instance is a running virtual server. It's the same as using your laptop or using one of these computers. It's just running on a host in Indiana or at TAC. So running is the instance is up, running, active. You can log into it, you can ping it, you can see the console. Suspended is the same as shutting your laptop, basically. So everything, the memory is preserved, it's written out to disk, it is off, but you can wake it up basically by unsuspending it, and it's again like opening your laptop. Stopped is literally like powering down. So you press the power button, it shuts itself down, and away you go. And then shelved is kind of the weird one in the middle. So shelved is you shut it down and it's off, and you physically unhook it from everything and put it on a bookshelf. So everything is still preserved, everything is still there, but to use it again, you kind of have to hook it all back up. And it's not as complicated as it sounds. It's literally, it's one command of unshelve the instance. But what it does is it frees the connection from the hardware. So if you are running, suspended, or stopped, you're using resources. So if you have a 44 core that takes up an entire Jetstream node and you suspend it, even though nobody's using it, you're still holding an entire node reserved. So it's not very nice. If you're just planning on going away for a few hours and coming back, or even a day, it's not that big a deal. But if you're going to go on vacation, you want to shelve things. So if you're going to be gone for, what my rule of thumb is, stopped and shelved. Let me back up. My rule of thumb is with suspended is for a day, maybe two. Stopped is anything more than that, up to say a week or so. And then shelved is anything after about that 7 to 10 day period, you want to shelve it. And that's just being kind. And it's also, freeing resources up for other people. Any questions on this? So flavors, and you'll hear me talk about flavors, and that is actual term. It's the size of the instance that you're going to want. So it's the number of cores, the amount of RAM, and the size of the disk. And those are predefined in the system. You cannot define those yourself. The hypervisor is what is actually running the virtualization. So when we launch an instance, the hypervisor is what's managing it behind the scenes. A snapshot is literally what it sounds like. It's a process of taking a running instance and turning it into an image. So you're taking a picture of as it is right then and saving it to disk, so that way you can boot from it later. It's a good way that if you've made a lot of changes and you want to test it out, you can take a snapshot of it, boot the snapshot, know everything is good, and then you can make a real honest-to-God image of it if you want to share it with people. And then the state. It's the state of the system. Are you running? Are you in error? Are there any other issues going on? And we'll see that when we start looking at the command line. You'll kind of see these things fall into place. I'm giving you these as kind of a preview for what's coming. The object store. So that's our Ceph storage system. It's a big blob with bits in it. So basically, the difference between it and, say, a library is a library has order. You have an organizational system that says these things go here in the Dewey Decimal System. The object store literally starts putting things wherever it can that makes the most sense. In our case, it optimizes both for speed and reliability. So it may put part of your file here and part of your file here and part over here, but it's doing that in a very logical way for it that defines where it's going to retrieve them from, where it's going to be most secure, where it's going to be able to serve them from faster. Block store is something like, literally it's like an unformatted hard drive. So in our case, it'll be a volume that we create to use with the system. Again, persistent and ephemeral storage. So persistent storage sticks around. So if you have stuff on a volume and you kill your VM, the volume is still there. VM storage is gone. So again, I can't stress it enough. Save stuff to a volume, save really important stuff offline too. Always know that if that VM gets deleted, it's gone. Now if there's a volume attached, everything that's on the volume is still good. So keep that in mind. And this is kind of the overview of OpenStack. So again, OpenStack is sort of the cloud operating system. It's what manages all the hypervisors. It's what manages all of the virtualization going on. So when you first log in, and we're going to do this in a minute, we're going to walk through this entire step from beginning to end, is you as a client, you log in and you're going to authenticate to Keystone, and that's going to give you a token back and forth. Now you don't actually see that, but it will actually get generated. And then that token you can talk to Nova, which is the compute aspect of OpenStack. So that's what you talk to actually launch an instance. Glance is where the images are. So the Glance library, and you'll hear me refer to the Glance library, is where all the images sit. And we'll see that list. Ceph is the storage system again. Cinder is the storage management system. So it talks to Ceph on your behalf. You don't actually talk to Ceph directly, typically. And then the compute nodes. So basically, from start to finish, what we'll do, we'll walk through this entire model and end up with a running instance that we can use. So we're going to go through it, and I'll talk about the different parts of OpenStack as we go. Okay, so the hands-on part. So there's a couple things here. You want to go to that Google link, and that will actually have the tutorial walkthrough. Now, I want to tell you, I know everybody has a tendency to work ahead in walkthroughs. I know I do. I'm going to encourage you not to, just because if you get too far ahead trying to track down where things went sideways, if things go sideways, it's often a challenge. And in the interest of time, I'd prefer to not lose you all. So from there, once you get that page up, we're going to log into a prepped host. And that host has all of the pieces, parts for the API client set up and ready to go already. So that way we don't have to worry about installing them on your laptop. And I'm going to give everybody logins. And I will tell you, the password that is on here does not work. Don't use it. But the username does. So you'll use the username, and I'll give you the password in a moment. Everybody got the web page up? Sorry, did I take that away before people could get it? Are you good?
Yes.
Okay. Are you good, sir? Yes. Good. Are you? Good. Okay. Well, then I will get to my web browser. So everybody sees this. Okay, if you scroll all the way down to the bottom, you're going to see that, the shared password. So that is the password for today. You will go to, where's my tutorial link? Here we go. So to access the server that we're going to go to today is SSH, whatever your training user is, so train 01, 2, or 3 at tutorial.jetstream-cloud.org. And yes?
So this is a Windows operating system. Should we need to download Putty?
Oh, is Putty not on here? Yeah, you're going to need Putty. Sorry, I just assumed it was going to be on here. For you all to get Putty a little bit, and I'm going to grab a piece of fruit because this is lunch. I'm sorry?
Do they have to install something?
No, well, Putty, SSH client.
I wonder if it'll let them do that though, because these probably all have admin.
Well, you don't really have to install it. You just save it, and then you can launch it. It doesn't actually have to install.
It's in this.
But the way it's set up, the security on these
Oh.
machines probably won't let them.
Yeah. Okay. Well,
I can see if I can find something in the library.
I'm surprised there's not putty on here.
Let me see if I can find somebody that can help, that can use one.
We used to have to install putty. Of course, I'm not a Windows user. I haven't touched Windows probably since Windows 95.
There's an executable you can download.
Yeah, that's what I was thinking, is if there's just an executable.
You can allow me to do it. What?
So okay, do you have putty installed? Okay. Okay. So let's go. Yeah, we're gonna. So search for putty, P-U-T-T-Y. First one. And then download. Scroll down. Binary files. Scratch 64-bit putty. Yeah. Yeah, so like that. So we'll launch putty. Oh, cool. Okay. You're actually going to want to have 2 sessions open to it. Should let you cut and paste the password, just so you know. But yeah, go ahead and open a second session to it, because we're going to need 2 at one point.
Oh,
Yeah, just figure I'll save you the time.
This one? Is it good?
It's good.
This is not this one.
Oh, Control C. Actually, go to your downloads. Okay, and then yeah, but change your training user to
To this.
to train 03, yeah. And then the password is the Triceracopter one from the bottom of that. You guys are both logged in?
yeah.
Excellent. Yeah, it should be okay. It won't show it. Yeah, do it. Just hit Control V one time, yeah. Turn off. Yeah, let me turn off fail to ban. That may be catching people. Oh, yeah. Okay. Try it again.
So, what should I just close again and run to that? Do you remember what it's?
It's active tutorial dot jetstream dash cloud dash cloud, yeah. Actually, it's a little hyphen, sorry. Instead of the dash.
Oh, instead of the word.
It's a hyphen, usually. Jetstream dash cloud dot copy paste.
Yeah.
Everything good? Okay. Are you good?
See how we do this.
Well, I don't want you to behind.
Should I just try to get it on?
Don't go. Okay. Excellent. Okay, so everybody's in. All right. So now that everybody's in, let me get back to my screen here. So we're going to talk today about the OpenStack command line. And this screen right here. Hey there. How are you?
Good, how are you?
Good. We'll get you caught up, actually. So that password doesn't work, but that username is the right username.
Okay, thank you.
And once you get set up, you want to go to that Google URL right there,
Okay,
and
all right.
you'll be logging into that host.
All right.
We'll give you a second. It's all good. Yep. Gives me time to eat my lunch. Okay, so you're, okay. Then you'll need to get an SSH session. So go ahead and start an SSH session into the host. And the password is actually at the bottom of that OpenStack document link, of that Google link you opened.
So which one? This one?
Actually, go back. You know what you for. Okay, so all the way at the bottom of that. So you'll SSH to, well, it's tutorial.jetstream-cloud.org. The username is down. Sorry. Okay.
Go back up.
There we go. No, sorry. One more. There we go. There we go.
This one?
Yes, sorry. There it is.
Okay.
So it'd be your user, it'd be train04 with that.
Okay.
And then the password is at the very bottom of that doc. It's Triceracopter, but it's with numbers. It's my extra special University of Cincinnati password. I like the Triceracopter.
I like this.
What's the command line for?
Well, you'll need putty.
Okay, let's see.
If-
You used to have putty.
If not, you can download the binary from putty. Yeah, there's a binary that's on there. Well, if you get logged in, we'll go.
Jeremy, what's like?
Putty is a Windows SSH client. For some reason in this day and age, Microsoft still doesn't maintain their own SSH client, and I do not understand why. But, you know,
Yeah,
I'm a
ways around it.
there are ways around it, but it's just, it floors me that after all these years, they still don't have one. I guess they figure, oh, putty's good, we don't need it. Are you logged in? Oh, okay. I want you to buy something. That's like an ad. Okay. When SCP or putty? Looks like when SCP. Okay, go back. Let's go back to your web browser. Just search for putty.
Oh, so I think this is, okay.
And just get the 64-bit binary. Okay. And then go to tutorial.jetstream-cloud.org. And grab the page. So train number 4. And then the password's all the way down at the bottom of this page. Copy paste.
This one?
Yeah. For some reason, cutting and pasting is not working. You might have to type it in. Okie dokie. Okay, so everybody knows this GitHub page that has the instructions that we're going to walk through today, this is always up. So if you ever decide you want to come back here and take a look at things, you can always come back on your own time as well. It's also linked from the wiki as well. I just want to make sure everybody understands that. So one of the things we're doing today by logging into a prepped host, what I've done is actually installed the clients, the OpenStack clients already, so we don't have to do that during class because that's fraught with peril for all sorts of reasons, especially on Windows boxes. But it talks, in this doc, we talk a little bit about installing the clients. The link to install the clients is here, so if you have a Linux box or you just want to install the clients yourself, you can get the latest clients and download them and install them. A lot of people use virtualenv. Is anybody here familiar with virtualenv? No? Okay. So Python, so all the clients are Python based. Python does a really cool thing that creates a virtual environment. So you can install everything into a virtualenv, and that way it doesn't pollute the rest of your laptop. It's all isolated and sits on its own. And I talk a little bit about that here. We're not actually going to do that today, but I wanted to make sure it was mentioned so that if you come back on your own, you can kind of see that. Get that off the screen. Okay. So a little bit of background. There's some documentation that's linked from here on using the API on Jetstream, and that's this link here. A lot of that covers similar things to what we're going to do today. It's not quite as complete. There's a note here about how you get access to the API side because you have to request it. And then a little bit more for programmatic access about using the software development kits for OpenStack. And then also about setting up the OpenRC. And so we're going to talk about the OpenRC here in a moment. But the OpenRC is basically your credentials for accessing OpenStack. It's what you use to talk to Keystone to get your token. So you've all logged into the host. Everybody's logged in. Typically, what you would do is you would create an OpenRC, and there's a link here on how you would do that. But if everybody gets into their account and types cat./OpenRC, you should see something that looks like that. Can everybody see that, my terminal down there? Is it too low? Is that better? Oh yeah, lights would be good. There's probably quite a glare on it. Sorry about that. Can you see it? Can everybody see it now? Okay. So,
Too dark?
hmm?
Everybody okay with this? Too dark? Okay, okay.
I won't let you fall asleep, I
Don't fall
promise.
asleep, yeah.
So what you see right here is, this is all exporting things to the environment. Are there any Unix users in here besides me? No? Okay. So you export things out to the shell. So these are environment variables that we're setting. And this is all telling stuff for OpenStack. So these are all prefaced with OS for OpenStack and then something. So we're telling it a project domain name, a user domain name, which are both TAC. TAC is the Jetstream authentication domain. So when you're using the API in Jetstream, regardless if you're using the IU cloud or the TAC cloud, it's always domain TAC. That's confusing. In retrospect, we would do it differently, but TAC is where the credentials are sourced from, so that's why it ended up happening that way. OS project name. So in OpenStack doesn't care about users. It cares about projects. That's not to say you don't have a user ID, but what it does mean is it groups things by the project. So all of you are in one project because all the trading accounts are in one project. And on Jetstream, that's an allocation. So if you have an allocation where everybody is on it together, you can see everybody else's stuff on the allocation. It's all self-contained. If you're on different allocations, you can't see his allocation, he can't see her allocation, etc. So it's a way of thinking about organizational structure. That is your username. So it's not that they don't care about usernames, but it's not that usernames are not important for organizational structure to OpenStack. So you've logged in with your username and your password, which is that little bunch of gibberish. And then this is actually the endpoint. So this is what you're actually connecting to. It's iu.jetstream-cloud.org, and that's a quick way to know which cloud you're connecting to because it'll either say IU or TAC. And we're using the IU cloud today. It's no reason either way, it's just I'm biased, I work for IU, so I tend to go to the IU cloud. We do ask that you never publish these. It's not a huge secret, but we're just trying to keep idiot script kiddies that like to beat on things not beating on us. That's it. And then the identity version is not something we're even going to worry about, but there are multiple versions of the API. We're on version 3, and this just defines it for OpenStack it tells OpenStack which version we're using of the client we're using. So as I say here, in the real world, you don't want to keep your password in a plain text file. I'm not worried too much today on a prepped host because one, I've got full control of the host, and it's going to be deleted tomorrow morning or this afternoon. So I'm not really worried about it. But typically, you could also achieve the same thing by telling it to read the password input. And this is actually on the website. It tells you how to do this. So you can set up a file that basically, it sets all those and then it asks you to type in your password. I didn't want to have to do that because typing these passwords that are randomly set for these trainings is a pain. So the next thing we do is we're actually going to cut and paste that source line that says source.openrc and put that into our window. And you don't get anything back. It'll just pop down to the next line. If you get something back, there's been a problem. Everybody good? We good? Okay. So the way we want to test that this worked is we're going to grab that next line. And I'm going to tell you what it does. We're going to say OpenStack image list, and then we're going to grep for a certain string. So if you're a Unix head, grep is second nature to you. If you're not a Unix person, basically what grep says is look for this string, match this string. Knowing Unix is not necessarily a requirement for using the API of Jetstream, but it certainly does help. The API is very Unix-centric in how it operates. That said, like I said, it's not a requirement. So we're going to take an image listing, and we're just going to grep out the featured API images. And so what we're doing at this point, we've talked to Keystone, we've gotten our identity. Now we're talking to Glance. Glance actually is the image store. So you should get a list back that looks something like this. Make this longer so it's all there. Everybody getting this back or something that looks like this? Good? Are you good, sir? Yeah. Okay, good. All right, so like I said, we did the image list. We just looked for the API featured, so that's what these are. And these are the ones that we maintain. These are the images that the Jetstream team maintains and tries to keep up to date. So we're going to be using one of these today. And what you see here are a couple things. So you see this horrible string of numbers, and then you see a human readable name. So that horrible string of numbers is called a UID. And that's actually what OpenStack cares about. OpenStack will let you use the name, but the UID is what it thinks of everything as. It's the key. So basically in its database, it has that key with that name and then some other information about it. You can use the names and the UIDs pretty interchangeably, and we're going to talk a little bit about that here. OpenStack will use either interchangeably. If you want to always make sure which one you're using, the UID is always authoritative. So a UID can only refer to one object. Things can have the same name in OpenStack. You can have two images named Bob. It'll let you do that. But the UID only refers to one specific version of it at a time. So a little bit about the command structure. And so you saw with that one, OpenStack image show. And that's pretty much how OpenStack, the command line works. So OpenStack command is the client name. You have the noun, so in this case it was image. We want to see images. And then show, which is show me an image, or show me the list of images. Actually, that's not what we did, sorry. We did OpenStack image list. You could do the same thing, OpenStack image show, and let's do that. So we're going to do an image show on this one, so we can copy and paste. And just do that here, and you'll kind of see what information you get back from OpenStack. God, that's horrible. That's a little easier to read anyway. So it shows the field and the value, and there's ways that you can pare this down and get just specific information. But you can see there's that UID again, so there's that big string. So that's what OpenStack knows it by. There's its name. There's the owner, which is going to be the project. And then here's the properties in the middle is just some metadata. And that properties line, whenever you see it in OpenStack, is just a bunch of metadata. It's fairly arbitrary, but it has very real meanings. And then you can see when it was created, etc. So that, again, knowing how the OpenStack client works is very important because you can kind of guess at a lot of things. The other thing is OpenStack has a lot of built-in help. So if you want to see all the commands for image, you can say OpenStack help image and it'll list all of those for you. So I'm actually going to do that just to kind of show it. And then we're going to show it on a specific one as well. So I'm going to say, just in general, OpenStack image show, hey, here are the things I can do. I can add it to a project, I can create, I can delete, I can list, etc. And then if I want to see help on a specific command, I can do the same thing. And this shows you OpenStack image show, and it'll show you what options are available and then what the argument is. So OpenStack image show, any of these optional arguments, and then you have to have the image name or UID at the end. So OpenStack tries to make it easy for you to use the client. It tries to be logical. Anything that has to do with an image will obviously be OpenStack image. Anything that has to do with an OpenStack server will be OpenStack server. And we'll be looking at those as we go a little bit. Again, here's where I talk about the names versus UID. They're interchangeable in the command line. You can have two with the same name. The UID is always authoritative, always authoritative. So we're going to create the cyber infrastructure for it. So you can also follow along in the dashboard, and we're going to get there in a few minutes. OpenStack has a GUI for the API side. And we're going to go there here in a minute, but we'll talk about that a little bit. We're going to create a security group. We're going to create and upload keys. We're actually going to build the network. We're going to start the instance. We're going to log in. We're going to shut everything down when we're done and dismantle when we're done. So this kind of walks you through everything step by step on how we get going. So it's important to know the first thing we're going to do is build a security group. So on OpenStack by default, security groups are the way that sysadmins have always wanted firewalls to be built. Everything is closed by default. You have to specifically open it. So the upside of that is you're fairly secure to start out with. The downside is that if you don't remember to open anything up, you can't even log into your own instance. So we're going to walk through creating that security group. So let's grab that first line of OpenStack security group create. And what we're doing here is we're giving it a description because you need to tell it what it is for you. It's a human consumable part. So we're saying we're going to enable SSH and ICMP, which is ping for people that are curious. And then that last part is basically saying read the OS username out of the environment, which is going to be that TG whatever name that was in the OpenRC, and call it TG whatever - global SSH. And you'll see that in a second. So let's grab that and try it out. And you should get a return back that looks something like this. And you see that it's named, in my case, TG455646. Yours will be slightly different, but it'll be TG something. Everybody getting that back? Good? Anybody not getting it back? How about that? Okay. Well, I'll assume that since I'm not hearing anybody say no, that we're good. So now we're going to create our next rule, which is to allow inbound SSH. And whoop. So again, we're following that that OpenSSH rule or command line format of noun verb. So we're saying create a rule. It's going to be TCP. It's going to be port 22, which is the SSH port. And we're allowing that from anywhere. That's what all those zeros mean. And we're adding it to this tool, to this security group. So you should get a response back that looks like this box below that basically says, hey, port 22 is open from everywhere. Everybody good? If you're not good, say something, because I'm going to march along unless somebody says we're not good. Okay, so now we're going to open one that says allow ping and other ICMP. And we're going to talk about that a little bit. I'm going to go ahead and create the rule. And you should get another box back that looks like that basically says protocol ICMP, remote prefix from anywhere. Everybody good on that one? Okay. So none of you are sysadmins, but ICMP is things that allow you to do pings and trace routes and do sort of network troubleshooting. A lot of people block ICMP because the first thing that script kiddies do when they go to scan you is they ping you. So if you get pinged, a lot of people think, oh, if you don't get pinged, then you're not going to get scanned. Well, yes and no. If you do a ping timeout, they're going to realize there's a host there anyway, and they're going to scan you without a ping after that. But the other thing is, ICMP, blocking all ICMP breaks a lot of routing self-healing things. So if you are doing, basically if you're at the router level, if you start blocking all the ICMP traffic and it needs to do redirects to get to another host, you can't. It just eats the packets. So you kind of break a lot of the features of modern day routing if you block ICMP. It doesn't buy you anything really to block it, but it buys you a lot of things to leave it open. And there's actually a link here about if you want to read why you shouldn't block ICMP. There's a good read there, but we're not going to dive too deeply into that today. Something else that we're not going to cover today, but I put a little bit about, is if you are going to create sort of a mini cluster, going to create things that talk to each other inside Jetstream itself, you can create things to talk on the internal network. We're not going to be doing that today, but this basically says on this unroutable 10.0.0 network, open all ports. And you want to be careful about that. I mean, your network is your network. Nobody else from the outside world can get you. But you want to make sure you never do anything like that on the external network, because then you leave yourself open to every script kiddie known to man. But again, if you're creating things that are, internal clustering, you might think about that. And then there's also a better idea of where you can restrict it to specific hosts. Again, we're not doing it today, but it kind of gives you an idea of some of the possibilities. So that said, let's take a look at our security group. So we're going to grab that command there and plug that in. And we should get a nice listing that shows here are all our rules that we've set. It's our group SSH and ICMP disabled. We're allowing ICMP on IP4. We're allowing port 22 down here from anywhere. And we're good to go. So there are the rules we added. So the other thing is you can add security rules after you boot an instance, and they take place instantaneously. So if you forget to open something up, you don't have to take your server down to institute a new rule. You just say, OpenStack security rule, create, just like you did before. So if you needed to open port 80 after the fact, or port 443, you could do that just the way we did before, and it would happen instantaneously. So you don't, like I said, you don't have to take your instance down to do that. You can also use that security group with multiple instances. That SSH and ICMP one is sort of my default go-to, so all of my instances by default get that security group. So I have probably 10 instances running that have that security group. You can share security group with multiple instances. You don't have to create a new one for each one. If you need something that's very specific for one, obviously create a new one. So the next thing is to actually log in. I'm sorry, do we have any questions before we go on? Good? Okay. So getting onto your instance once we boot it will be through SSH. So to be able to access it, we need to set up an SSH key. So that first line is actually an SSH command to create some keys. So let's do that. Now, if you already have SSH keys and when you start to set up your own instances, you can use your existing SSH keys. You don't have to create a new one. We're doing this just for the sake of the tutorial because I didn't want you guys to use any real SSH keys you had, and I didn't want to assume that you'd have them. So we're going to go ahead and create. So you should have gotten something that looks kind of like this back, a nice little ASCII art. And if you actually look in your directory, you should have these two keys. So you have a public key and then you have the private key. Everybody good? We get SSH keys created? No? Where did I lose you?
Just a second.
Okay.
I got to this point.
Okay. Oh, if you do ls,
Get it all
all lowercase. Ls space, minus,
minus.
LATR. Yep. See down there at the bottom. Sorry, I forget that not everybody is a Unix head. I've been doing Unix stuff for 25 years, longer. So 27 years. So it's all second nature to me. But this is where you can see your keys. You can actually see your OpenLRC file sitting there, and then there are your keys that we're going to use. So let's drop back to the tutorial page. So we're going to upload that key to OpenStack. So again, OpenStack, and then noun verb. So we're going to say OpenStack key pair, which is what we're going to move, and we're going to create it. And we're saying this is the public key, and we're going to take that file and that private and upload it into our account. And you should get this little box back that says, hey, this was successful, here's your key, there's your name, there's the user ID that's associated with it. Everybody good? Okay.
Mine
Uh,
said expected one argument.
I'm sorry?
I return error saying expected one argument.
Let's take a look.
It says one argument, expected one argument.
Oh, it got wrapped.
Oh, okay.
Yeah, you need to get that all together as one.
Okay,
Yeah.
thank
Yep. Yeah, sometimes cutting and pasting, that's why I've made the window so wide, is that way it doesn't get wrapped around.
you. Okay.
Plus it looks nicer to show on the screen. So the other thing you can do, and we'll do this, which is the optional, is we can, like anything else, you can take a look at it and say OpenStack key pair list. So if you have more than one key pair, it'll list all the key pairs that you have. Now the interesting thing here is I talked earlier about how everything is done by projects and that everybody in your project can see your stuff. This is the one thing they can't. So your key pair is indeed unique to your user. Nobody else can grab your key pair. That's the throw to security right there, is because obviously if somebody has your key pair, all bets are off. I mean, you should be able to trust anybody that's on your allocation with you, but just in case. Maybe you have a lab partner that wants to see you fail, and we don't want that to happen. Did you get everything back?
Let's see. No, I didn't get that. It says key file, error, no such file.
Okay.
Yeah, do I need to change this to?
Oh, hang on one second. I see what's going on. Yeah, let's create new keys. That got wrapped around too.
Okay.
So you can actually just change it to be that name if you want to.
Okay. So change to this name.
Yeah, actually you can, so here's what happened. I'll show you what happened. So where it got wrapped.
Okay.
Yeah, that's where it got wrapped. Oh, it just had $train04 because that
Oh,
the
okay.
environment doesn't know about that.
Okay. Yeah, I should change back to this. Okay.
Okay.
So just stick with OS username.
Yeah, it has to have that full
Okay.
thing in there.
Thank you.
I'll wait a second for you to get caught up. It's not a big deal. We're doing well on time. So the other thing is, once you do this key pair list, you get this fingerprint out here, and that's an MD5 sum. So if you're truly paranoid and you want to make sure that everything came through exactly the way you expected, there is an SSH command that lets you compare your local key and the external key. So you can actually run that from here, and that gives you an MD5 sum. And as you see, these two should match, and if they don't, you have a problem. Wait 1 second for everybody to get caught up. Are you good? Yep, you're good. Okay, good. All right, we will move forward. Okay, so the next thing we want to do is look at the dashboard. So there's a link in there to the IU dashboard, so you can go ahead and click it to get your dashboard up. This other instance logged in. Okay, so let's do this. Okay, so if you need the login ID, you can get that from your OpenRC file, and I talked about that Here, let me get back to it, sorry. Okay, so in your OpenRC file, if you can cat it out. Again, I keep forgetting you guys are not Unix guys, so you can type cat, C-A-T, openrc.sh, and you get that file, that back up again. That will be the username for the IU portal, and then that will be your password. I mean, it'll be different for each user, but that'll be what you use. So I'm going to grab mine and log in. The domain is always TAC, like I mentioned before. So everybody seeing this screen, the OpenStack? Oops. So, I'm going to click project here. So to talk about this, click the overview screen. I'm not sure where you log into. I've got some weird things set on mine. So this actually shows you the overview of your allocation. It shows you what's in use. You can see that there are 5 security groups in use. So 1, 2, 3, 4, 5. That's all of us. Kind of gives you an idea. This is from the compute overview, by the way. Yes? Okay, not a problem. Okay, so you can change your username to be that, TG. So you're probably also wondering, why are we using the command line if we could do all this in the GUI? There are a couple of reasons. One, it's my opinion, and this is because I'm an old school Unix guy, is that knowing the command line helps you understand what's going on in the GUI. It helps you understand what's going on in the whole system. The other thing is there's actually parts of this that, in my opinion, are actually easier on the command line. Setting up a network, for instance, the first time in the GUI is, I find, terribly confusing. So we're going to do it. We're going to do it my way, and then you can explore on your own later on down the line. But there are full instructions on our wiki as well for dealing with this too. We're just not going to cover creating things in the GUI today. I want to show it to you for one particular reason, though. So if you click down here on network, bless you, on the side, the first option is network topology. And you're going to log into it, and this should be all you see right now. You should see public and then these 2 networks that are sitting out here on their own. Everybody see this? Getting a very confused look. Are you good?
Switch to graph.
Oh, yeah, sorry, yes.
Yeah, but we don't have that.
Yeah.
Part label.
Oh, I've got the labels turned on.
Okay.
Yeah, if you click toggle labels, it'll turn it off and on.
Oh, okay.
So this is all you see right now. As we build things, this is going to change. So I like to use the network topology for troubleshooting. Also, if you're building anything terribly complex, this is a great tool. So we're going to flip back to the tutorial. I just wanted to get you all logged in here. And we're going to create our network. So the first thing is we're going to say OS network create. Not that one. And we should see, come back, see, here we go with admin state up. We've created a network. It's been given another UID. It has our name, which is, in my case, TG455646-APINet. And it tells us when it was updated. And so let's take a look at the network list. Whoops. And so here's where you see that we can all see each other. So we see all of our networks in here. I see 5 networks, so that means everybody's along with me. This is where it gets nice because I can see who's behind. So there are all our networks. Now here's the thing. If I were feeling particularly malicious, again, this is how we talked about, I can delete this network. This is why when you're working together in an allocation, you have to be very mindful of what you're doing. And I'll relate a funny story. We were doing a live demo tutorial at a conference, a colleague of mine and myself, and we got to like the last 15 minutes of it, and we were kind of off the grid at that point. We're just kind of showing some cool stuff you could do. And I figured, oh, while he's doing that, I'll do some cleanup. And I deleted his instance out from under him that he was using right then. During the thing, he's like, why isn't this responding? And I'm like, oh no.
Does it allow you to do that?
It does. Well, anybody on your allocation is in your group. So you can see their stuff, you can delete their stuff. That's why, you should always trust whoever you're on an allocation with, which is particularly, you're pretty much going to be like your research group, things like that. But it's also paying attention to what you're doing, which I wasn't that day. And he hasn't let me live that down yet. It's been almost 2 years now, and I still hear about it. We're doing another session together in July, and he's already told me, don't delete my instance out from under me. It's like, it's 2 years ago, man. All right, so we've created a network, so we're going to create a subnet. Whoops. I don't know why I have OpenStack subnet list first, but we're going to say OpenStack subnet create. And we get that back. We've created a subnet, and we've given it, right here, we gave it a subnet range, so we gave it our internal range. /24, anybody here know what slash notation is? Okay, kind of figured not. So slash notation tells a router how big your network is. In this case, a /24 is 255 addresses. It goes everything from, you can go /16 all the way up to /32. There are great tutorials online that explain it. I am not a networking guy. I could not begin to tell you why this evolved or how it evolved. So if you ask me why or how, I'm going to say Google it. I wish I could be an expert in everything, but I'm not. You can also, again, like everything else, we can look at the subnet list. So there's everybody's subnets. I see 1, 2, 3, 4. Uh-oh. Somebody's not along with us. Who have I missed? Oh, are you not along yet? Yeah. Now you are? Okay. Yep, there we are. Cool, so everybody's along for the ride. And you can also see, as you notice, we all have the same addressing, but it doesn't matter because we created our own networks. So our networks are isolated from each other, so we can have the same IP space, even though we're all in the same project together. So the next part is we're going to create a router because we have to be able to get things from our network outside the network. So we're going to create a router, and that should come back with the normal OpenStack box. Here we go. Here's our router. There's our router name. I can, like anything else, I can say OpenStack router list. And there's all 5 of our routers. Cool. We're going to jump to the next one, and now we're going to attach the subnet to the router. So here's where we start our actual routing part. That should come back. And then we're going to connect it to the external network. So one thing you notice here that we have to take 2 steps to be able to route to the outside world. We have to connect our subnet to the router, and then we have to connect the router to the outside. In some OpenStack deployments, you can connect your subnet directly to the outside and not have a router. It was a very conscious decision on our part to force everybody that the public doesn't talk directly to any subnet, and that's for protection. So we've basically made an intermediary step where you have a non-routable network. So anything in your network can only be seen by the outside if you make it seen by the outside. So we thought that was a good idea. Not everybody agrees. So here's where it gets interesting, however. So let's go back to our network topology. And you should see all sorts of things now. Let's actually refresh that and see. We'll be able to see everybody if everybody's connected. Yep, we have one person who's not connected yet. But you can see everybody that's on board has your subnet, talking to your router, talking to public. I don't know who isn't along with us yet, but can I help? Or are you good?
I don't know.
What's your TG number?
Well, that's what I was trying to figure out among all of these, which one's on. So go on.
So if you cat that OpenRC again. So you are TG 455609. I think.
Okay, I'm good.
Yep, you're up there. So you were not online?
Yeah.
Yes.
Oh, you're good now? Okay. Everybody good? I want to refresh and make sure. That's the nice thing. But this is, again, this is a great tool that lets you see, how the network is set up and how it's all connected. And again, if you're doing something complex, you can kind of get a figure here for what's going on. So everybody is hooked up, everybody's talking. You can actually also get information about each of these if you click on them. You can gleefully delete things from here. Please don't. Now you're just teasing me, aren't you? You can see router information. You can see pretty much everything here, which is nice. You can see that everything is up. So I like this as a nice troubleshooting tool. A lot of people use the Horizon interface all the time. That's what this is called, is Horizon. So now let's go back to our tutorial page. So we've looked at our interfaces. Now we're going to start looking at getting things going. So we've built our infrastructure. Now the upside is once you've built this network, if you're going to do a lot of work on the API side, you can build a network once and just leave it up. I do. It doesn't take any resources. It's basically just a handful of bits sitting on a server that have things running and routable. So if you're going to create things and tear them down, instead of going through this every single time, you can set that network up one time and just leave it. So let's take a look at the flavor list. Now we talked before, let's start from a clear screen, that flavors refer to the sizes of the instances that are available. So I did a flavor list, and you can see the M1s, so from the tiny, which is 1 vCPU, over here, sorry, the small 2, and you can see them growing from there. And then you can see the S1s, which are the storage instances that have larger disk available to them. So these are the size VMs that are available to you, which is important for launching a VM. So we're also going to get our image list up again and look for the image that we want to run. And so this is like what we did before. So you get your image list. And hey, I like that CentOS 7 image. So the reason we also say to look for the JS API string, these images, go back to it, these images were built on the API side. We know they work on the API side. If you get some of the images, you can see all of the images that are in all of OpenStack here. So let me actually show you. OpenStack image list. Oops. Rep MATLAB. So I'm just doing this as an object lesson here. So this first one, this is an atmosphere image that has the MATLAB image. You can boot that over here. We don't guarantee that it works over here. We know it works in atmosphere. We don't know that it necessarily works on the API side. It should, but we can't guarantee it. So that's why we always say when you're going to boot something over here, especially for the first time to build, always look for the ones that are JS API, because those are the ones that we built specifically to use on the API side. So we're going to boot the instance. And so there's this big command line here, and we're going to talk about that a little bit before we actually do it. So OpenStack, noun, so is our server. verb is create, and we're going to give it this name, which is our username with API U1. We're telling it flavor is tiny, so it's going to have a 1 CPU instance. We're using this image name, and you can put the UID in there as well. We're using this key, which is the key we set up earlier. We're using this security group, which is the one we set up earlier, and using this network. So we're attaching our NIC, our network interface card, to this network that we set up earlier. This is an optional. I'm telling it basically, I've got a file that got copied into everybody's account that says don't force updates on boot. One of the security things for IU is every time you boot an instance, you get patched up to the latest operating system level. It can slow things down a little bit. We keep those fairly up to date, but for the sake of a tutorial, wanted things to boot as quickly as possible. So we're foregoing that, which is not good practice. And then wait basically tells it don't come back to the command line until the server is booted. So without further ado, let's copy and paste that. And you should get all of these ands, and that's normal. Don't panic, that's normal. And then just hit return at the last one. Just so you know, from a Unix perspective, these slashes tell the command line, tell the interpreter, I'm not done yet. That's why you get the and. That's on purpose. I'm going to turn you guys into Unix guys before it's all said and done, just so you know. You're engineers, right?
Yeah.
Oh God, I want to get you to Unix, but God, Windows is the devil's work. I may have strong opinions about this. Seriously, it can't hurt for you guys to be proficient in Unix. It can only help. You may or may not need it. I don't know what the engineering world's like these days, to be honest. But I honestly don't think it could hurt you to be Unix proficient. So it would make me happy for you guys to be Unix proficient.
Yeah,
You know, me being happy is important, right?
Yeah.
Don't answer that. All right, so everybody get back to the screen. You have an instance coming up. Okay, so you see it saying active and running with a whole lot of other information here. You see your UID for the instance is right there, so that is the unique identifier. We're going to jump back here. So we're actually going to attach a floating IP. So this is a little bit of jargon here. So a floating IP in OpenStack parlance is it's the IP from the floating pool, which are typically public addresses. So we're adding a real, honest-to-God, routable address to your instance, so you'll be able to get to it from outside. So let's go ahead and do that. So this part is actually, we're grabbing a floating IP out of the pool. And so it comes back and says, yep, here's your IP, and whoops, there's your floating IP address, sorry. So we're going to need to have that, so keep that handy. We're going to come back here, and we're going to bind that IP onto the instance. So don't grab that whole command line, stop before the end there, because the URIP here is where we're going to paste in the other part. So paste it in, don't hit enter yet, and then grab the IP number from up here and paste it in. So everybody see your command line like this. OpenStack server add floating IP, your instance, and your IP. Hit the button. Okay, so that has added that. So if you now do OpenStack server show, oops, I didn't give it the full information. You need to get that UID. Or you can do it with the name. So I'm going to say, grab this, OpenStack server show that, and we get that back, and here is that floating IP has been attached to it. So we have our internal IP and we have our external IP.
What did you get that to show?
I'm sorry? Oh, if you come back up to where you launched it, you can grab that. It's the OpenStack username, API U1. I think that was actually in here. Whoops. I need to add that into this tutorial. I didn't actually add that. So we're actually going to ping it. So what we're doing, we're pinging the instance, so I'm pinging that IP number. And so from this host, we're actually talking to that host. It's routable, it's out there, it's available. So if you ping it, you should get something that looks like that back. You're making faces, that's not good. That's okay, no, you're good, you're fine. What do you-
I think I'm getting this. Open space commercial.
Oh, there needs to be space.
That's, okay, that's what, and I do not add space after it's all.
Sure you can.
Can I?
Yep.
In Bash, which is the shell we're using, you can actually use the up arrow to go back to old commands.
Oh.
It's very useful.
So it's, I only have the first line, is that okay? I only have that 56 bytes of data.
No, we're not pinging it.
Okay.
So let's do, hit Control C. Okay, try to go ping it one more time, do the same ping command. Okay, so this sometimes happens, so hit Control C again. And do OpenStack, basically take this command and do OpenStack server del floating IP.
Now,
Delete.
okay.
OpenStack server delete.
Okay.
Sorry. All together. You have to spell the whole thing out, sorry. Or actually, just maybe remove. Hang on one second before you do anything. I want to make sure that that's right. Yeah, it's server remove floating IP, sorry.
Okay.
So OpenStack server remove floating IP. And then you need to get the go back up.
Oh, that, okay.
Yeah, you need the server name and the IP address, and then just re-add it. Sometimes that happens.
So, okay.
Well, I mean, you still need if you scroll up, yeah, you can scroll up and just grab that tail end right there.
This one?
Yeah, from the you need the $sign now. Yeah. All the way to the end.
How do you copy and paste? I tried this, that doesn't look so easy.
Should be able to
Yeah, I never copy and paste.
should be able to control V.
Okay.
It's in the wrong. Yeah, you need to. That should be at the end after that.
Oh.
It's basically that same command. Instead, if you want to make it easy,
Mhm.
scroll up. You just change that.
Oh, yes.
Oop.
Since that's removed.
Actually,
Okay.
yep. Okay, and then scroll back up to that add and add it back.
Okay.
And now try to ping again. That's weird. I don't understand why that's happening. Okay, hold on for a minute. Bless you.
Yeah, that's really annoying.
There. Everything's good. Okay. Well, this doesn't stop us from moving forward, but that's still bizarre. I have to dig into that one. I'll probably leave this one up after the tutorial's over and figure out what's up. Okay, well, we're going to keep moving on. All right. So to actually log in, and I apologize, you're not going to be able to do this. This is the one step you won't be able to do, pretty much. Well, no, that actually is multiple steps you won't be able to do. We should probably try to get this working. I just realized that it's going to be multiple steps. Let me figure out what's going on. Sorry, everybody. We'll be right along in 1 second.
Did I successfully allow that?
Yeah, it's a great question.
I did copy and paste, but it may not work.
Don't.
I'm 10, that's right.
Yep, there it is right there. SICMPLL. It does have the right TG 55610 global SSH. There it is. Now that should work. So, okay, it's still not working. So we're gonna take more extreme measures.
So this whole thing, we should, this is what we should do before we started everything, right? All these network.
Yeah, the network
stuff.
is normally you would do one time and just.
Before we and then set up.
Okay, so let's boot another instance.
It's always the same. Yeah, I checked it for almost 50, 60, like manually, literally it's that's fine. I'm not wasting my time.
So the network we build is mainly for like storage, the file transformation.
No, that's for getting in and out. I mean,
Getting in,
yeah,
okay.
yeah.
Okay.
It's for all transit to the instance. So let's.
I have chance. I know chance I have 3 sheets.
That works.
One is flat PSW and speedometers level.
Really?
Same thing on our side. If it's
That's
the
a new
same, put
instance.
one by one.
That should just work.
If it's not the same, whichever is
Okay.
not
It's
the
working
same.
now?
put the
No,
same. So like we-
and I don't know why it's not working now.
We can show more. This was the change, or this is
Okay, go
what
ahead.
changed, right?
I think in the interest of moving along,
Yeah.
this means you won't be able to do some of the commands. I apologize, but all right, we're gonna keep moving along. That one is broken for reasons that I cannot understand. I'll have to troubleshoot that one later. Everybody else, let's try logging in. So we're gonna say SSH in with the username is CentOS. Since we're using a CentOS, that's a default user that's built in. If you're using an Ubuntu instance, it would be Ubuntu. And then use your IP number. So let's grab. So it's CentOS at IP. And you should get a thing that says, are you sure you want to connect? And you say yes. And now you are logged into the instance we just created. And you can kind of verify that if you want to say uptime. It'll say, we've been up 13 minutes. It's one user. You can kind of look around if we want to. So you see the file systems here. You can become root here by doing sudo. Sudo, by the way, SUDO is super user do. So that you're root if you do that. With great power comes great responsibility. So you have the ability to screw up anything you want at will. If you wanted to do an rm-rf on your site, on your root file system and delete it all out from under yourself, you can. I have highly advised not to do that. So this was just logging in to show, hey, it all works. So we're good. We're going to go back out to our thing here. We're going to create an OpenStack volume. So we need to get back to the other host for a minute. And this is why I have two of these running, by the way. So I'm going to say OpenStack volume create. Whoop. Oh, because I don't have. Okay. So I've created a 10 gigabyte volume. Move this kind of up a little bit. It's actually creating right now. If I say OpenStack volume list, we can see the volumes that get created.
Should we be doing that too or not?
If you want, at this point it's kind of optional, but
It's a command, not from.
oh, are you still on? You need to show out the other one, so go
I
ahead.
don't have the other. Should I have, should
Well, you can, but you can also just say exit from here, and you'll be back at your other host.
I put this?
Yeah,
And then go
then it'll work there. Yep. Okay, so anybody else been able to create a volume? Yep, there we go. There's another one. Are you good? Are you having problems? Or no, you're good? Okay. So we have 3 volumes. So what we're going to do is we're actually going to connect it. So we've created the volume, and now we're going to say, add this volume that we just created to the server. So we're basically giving it the name of the server and the name of the volume. And if we now look at our OpenStack server show this, you don't have to do this. I'm just doing this to show a point, or to show what's happening. You can see the volumes attached here now has our volume. Let's see where everybody else is. Okay. Alrighty. So let's go back in and to the instance and take a look. So you need to you need to shell back in the same way we did before. So you can just up arrow to that command and hit enter. And then do the root command, which is in the tutorial, like I explained. And if you grab dmessage SD and grep SD, dmessage and pipe into grep SD, which is in the tutorial, right here, you can kind of see where it's attaching. So the last thing you should see is should say dev SDB or attach SCSI disk to SDB. That lets you know where it's attached itself, so we can mount it and actually use it. Everybody here yet, or did I get too far ahead of you?
So I cannot do this.
You can't, yeah.
Okay.
Without being able to get in, I apologize.
That's fine.
Yours is being cantankerous, and I don't understand why. And I need to spend some time trying to figure it out, but I don't want to.
Okay, sure.
Yeah. Most of the time when I do these, I usually have a helper with me, which helps a lot.
So what do we now? We go back to.
I'm sorry?
What else?
So have you logged back into your host?
I think so.
Okay. Did you do the sudo su command?
No.
Okay, do that.
What's the password for sudo?
You shouldn't have a password. It should just work.
It prompts for a password. Should I just enter?
Oh, that's because you need to be on your instance, not on. That's my host, isn't it? Yeah. You need to be logged into your instance. Have you logged in already? Go down. Oh, sorry, go back up. Okay, right there.
This one.
Yeah,
Okay.
and then you need to, your IP now. Yeah. Okay, everybody able to get the D message? Yes. No? Okay. Let's see where you are.
I am assume.
Okay, so that's where you, let's go back in here and grab that D message.
That's up to here.
Yep.
Two
Yep.
days, they just have to.
Okay, and so there, yeah, you see what you should see. Everybody seeing something that looks like that? I know, sorry. Everybody that has a working instance presently is seeing something that looks like this. Okay. So what's important here is this last line that says dev SDB, or sorry, it says SDB attached SCSI disk. So that's where we just, when we did the OpenStack volume attach, or add volume, that's actually where it put it. So the next thing we want to do is we want to make a file system on it. So back in the tutorial, we grab the makefs command. Make sure you're in your instance. And you should see it start doing its thing. So what we've done is we've told it make file system type XFS, which has meaning to Unix people. This is the technical data on it. It's dev SDB, which is going to be important in 1 second. So we're going to make a test mount for it, which this is in the tutorial as well. So make the test mount. And that's saying make dir test mount. And now we're going to actually mount it. And then if we do the df-h command, which is in the tutorial, you should actually get output back like this. And this shows what's mounted and how much space it has. So you can see dev SDB is mounted. It's 10 gig. We've used 33 meg of it. The system has. There's still 10 gig available, and that's where it's mounted. Did that work for you guys? Okay. Okay, so we're going to start doing a little cleanup on this. So we're going to unmount the test mount that we just did. So again, from your instance that's running, do the unmount test mount, and you can verify that. You don't see it in your DF list. So it was here, we unmounted it, now it's gone. This is all Unix underpinnings. So everybody good? Okay. We're going to actually delete the volume at this point. So this is back from the shell host. We can log out of the instance now. So you can just log all the way out. If you type exit twice, you should see you log out, you basically should see it say the connection is closed and you're back at 177 train whatever username. Everybody back to everybody out of their shell or out of their instance? Okay. So let's actually delete that volume we just created. So we're going to say, we're going to remove it from the instance first. So we've unmounted it. We're going to remove the volume from the instance. And you don't have to do this one. I'm just just going to show everybody that that is unmounted now. So if you look and see where volume's attached, we have no volumes attached. And that's what it should look like. So let's go ahead and delete our volume. And if we do an OpenStack volume list, we should see that list start dropping. So we just see the one that's left. Oh, it's still attached. Who's still attached? It's not you. You're 09. One of you still attached? Yeah. Trying to figure out who 10 is.
10 is me.
Oh, okay.
Yeah.
Oh, you're cool. I'm gonna leave your instance up because I want to play with it. So I want to see why it didn't work. Cool. Okay. So we're not going to do any of these. Do not do any of these. We're just going to talk about this for a few minutes. This is a hands off the keyboard moment. So if you wanted to reboot the instance, you can do it from the command line in the Unix way, but you can also use OpenStack commands. So you can say OpenStack server reboot and then the server name. If you need to do a hard reboot, and a hard reboot is literally like unplugging the thing, you just need it to go right now. There are times you'll use a hard reboot, they should be rare, but if something is just stuck and it won't come back and you've given it 10 or 15 minutes and you cannot get it to respond at all, sometimes you have to do a hard reboot. It happens. I mean, this is just an operating system like everything else. So sometimes you have to do that and you say OpenStack server reboot instance name -- hard. And that tells it the difference between a soft reboot, which is pressing the reset button, and then hard reboot, which is literally yank the power out from under it. If you want to stop the instance, you want to shut it down into a stop state. It is not running anymore. It's like you literally power it down normally. You would say OpenStack server stop, and then you could start it again by saying OpenStack server start. Again, subject verb every time. If you wanted to suspend, which is basically like shutting your laptop, it's pause and unpause. Suspend, it's lower, my mistake. I don't know why that's still there. We don't usually pause the instance anymore. And then, like I said, the normal nice, I'm going away for a little while, shelve and unshelve. So these are the different things you can do to manage it. So whenever your instance is running, you are burning service units, you're burning core hours. So if you're going to walk away from it in the instance of preserving that, shutting it down is the nice thing to do. If you're going to be a while, if you're a week or two, shelve it. It's just nice. It's the nice thing to do. Are there any questions up to this point? Everybody good? Okay. So dismantling what we've built. So we're going to be kind. Actually, I don't want you to dismantle what we built. Is that okay? Okay. Cool. So the rest of us are going to dismantle what we built. So let's grab the commands in here. So we're going to remove the floating IP. And don't grab your IP number here. You have to get that from your instance. So if you don't remember, you can say OpenStack server show. Oops. Great. Let's just try that again. So I'm saying remove the floating IP from this server, this IP. And the reason you have to specify the IP is you can actually attach multiple IPs if you have multiple routed networks. Some people do that. Sometimes you might need to. So you always have to specify which IP you're removing. And we can verify that if we really want to. And again, you don't have to do this. I'm just showing it. And you can see here, that public IP is gone. Hooray! So we're going to return that back to the pool. So what happens if you don't do this? You hold that IP open. Nobody else can use it. So there's an upside. If you're doing a gateway development thing and you want to take something down or build a new version of it that have the same IP, you can keep that IP. But if you're not going to use that IP again, the kind thing to do is return it to the pool. But the upside about using the API side is you can keep that IP as long as you need to. So if you're building a service that is available and you have a nice DNS name that goes to it, you can keep it. So in this case, we're not going to. So we're going to be kind and we're going to return that to the pool. And there we go. And then we're going to delete our instance. Should be gone now. So at this point, from this point, and we're going to walk through these because I want to take it all down. Typically, though, like I said, you set that network up one time and you just leave it up. There's no reason to take the network down unless you are really just not going to use it again. So if you were just creating a normal project and you wanted a test network to leave up all the time, we wouldn't do any of these. It doesn't use any resources to leave a network up, only servers. So since these are training accounts, we're going to take it down, but I want to stress that if you're doing work on the API side and you want to leave a network up, it's no impact. Feel free to, and you don't have to walk through all those steps to create it again. I leave mine up all the time. It's just easier. That way I can just boot an instance at will. So the first thing we're going to do is unset the route. So we're basically unhooking the plumbing, and we'll see it in Horizon in a minute. And then we're going to remove the subnet. Okay. And we're going to delete the router. Basically, we're just unmaking everything we made. And we're going to delete the subnet. And we're going to delete the network. And we're going to delete the security group. And finally, we're going to delete the key pair. So now at this point, if I say, OpenStack server list, I should just see our one running instance, which is the one I need to go back and troubleshoot. If I do the same thing and say network list, I should hopefully just see, yep, there's just the one. Same with routers. Apparently I can't type today. Yep, just the one router up. So now everything has been deleted. There are a few things in here that I want to talk about at the end. There's a tutorial here, which is one that talks about building a small virtual cluster using Jetstream. And there's two other projects. One is my colleague Eric, who is doing this one here. And then another one is the HPC toolkit, which he's working on as well. This basically is just the quick walkthrough and the basics. There's a lot more that can be done with this. I mean, more than we can cover in an afternoon. I mean, it could be weeks worth of tutorials if we really wanted to, and I don't want to bore anybody. But there's a lot that can be done with this. So we've kind of reached the end of what we're going to cover today. So I wanted to see if there are any questions about what we've done, about what you can do, about what you might want to do, anything. The floor is open.
Yeah, sorry, I'm new to this. So the whole purpose of doing this is just to set up a network so that we can connect and run the instance?
Well, the purpose of running through it is to showing all the steps that go into bringing an OpenStack instance up from start to finish. So we build the network, which is the most complicated part. And then we launched an instance, so we had a server that we could use.
Okay.
And then we couldn't on yours, but we could log into it and then go to work. And typically, you set that network up one time, and then you can launch as many instances as you need to, or one at a time, and then another one, and then another one.
So without doing this, you cannot do any of those images. You cannot open the virtual
Right.
machine
You
or
have
anything.
to. In the API side, you have to set up all your networking first.
Okay.
And so this was just kind of walking you through that. Again, you set your network up typically one time, and then the next time you just launch a server, and then you just go to work.
Okay.
In the Atmosphere side, it's a little different. So one of the things that Atmosphere does for you is it does all of the network plumbing. You don't see any of this from the OpenStack side. You go, launch an instance, and that's it.
Okay.
And you lose a lot of the ability to do customization. So if you wanted to do, say, a virtual cluster, you can't from Atmosphere because you don't have any control over the network.
Okay.
But if you just I just need a server right now to get some work done, Atmosphere is literally go find. I'll show you. In fact, let me just do that. So this is not whoops. This is not today's tutorial, but we're going to log in real quick, and I'm just going to show you what happens. So we're going to grab an image. So say we want to start a MATLAB instance. I just want to go to town working on MATLAB right now. So here's the image. I say launch. Let's give it a name and say this is UC test, because you can have multiple with the same name, and the problem is that if you don't name them uniquely, then finding which one you want later is a problem. I tell it what provider I want, so Indiana or attack. I tell it the instance size, so by default you get 6 cores, but you can go larger than that. And then I say launch. And you sit and wait for a few minutes. However, I have one I started earlier, so I'll show you logging into it. It's the difference in the API side versus Atmosphere is, Atmosphere is good for people that just want to get in and get stuff done.
Okay.
API side is you have some specific infrastructure you want to build. You want to build a gateway. You want to do something where you need control over the underlying network and the infrastructure.
Okay.
Most people, we have roughly 100 API users. So out of just shy of 2,400 users, that tells you where most of our users are.
Okay.
So here's the one I started earlier, which was test launch. And I can say, give me a web desktop. Use MATLAB.
Okay.
It'll take a second because one, it's got to talk to the license server, so it's doing its thing. Plus
So any of those images are not, this is not like MATLAB server, it's still opening a virtual machine, right?
Yes.
That you run it on the machine.
Yeah. Well, I mean, here's the thing. When you use MATLAB's serverless service, they have a VM running. It's kind of like Amazon Lambda, where there's something running, you're running on it, you just don't realize it.
Okay.
So I've launched an instance that has MATLAB on it. So,
Okay.
but that other one is probably in progress. We'll see where it is. So our test launch is building. So what's interesting here is you can see it's got its IP number. It's actually doing its thing.
So that IP number is the same as the one we set up.
Well, it's going to be it'll get a different each instance will get a different IP number.
Okay.
And in Atmosphere, it just goes through it randomly, says, but it's the same exact process. It's just doing this. What Atmosphere does is it does it behind the scenes, so you don't ever see it.
Okay.
So again, you lose some abilities, but if you want simplicity, like if you just want to come in and I just want to use an instance and do some work,
Okay.
that's where you get the advantage here.
Yeah. But the network you always need to set up before even for like Atmosphere you need to set up.
Nope. Atmosphere does it for you.
Okay, so you don't need to set up the network.
Nope.
Okay.
Yeah.
But this network setting is only for API.
Only for the API side.
Okay.
Yeah. That's the thing. Is the API side gives you access to that.
Okay.
The Atmosphere side doesn't, and it's plus and minus. I mean, if you're somebody, if you're just coming in and you want to use MATLAB, or you want to I just want an instance right now to do work. I don't care about doing anything special.
Okay.
I've just got my research to do. Atmosphere is the right place to be because it's not complicated. You come in and do your thing. Where you want to be on the API is if you are setting up a gateway, if you are setting up a persistent service, if you're setting up something that needs crazy networking, like you want to do a virtual cluster. Basically you need to be able to route internally. Anything where you need to have network control, you need to be on the API side.
Okay.
If you just want simplicity, I want a machine to do a thing,
Okay.
Atmosphere is it.
So if I want to do like a gateway or web page where people can access my method of data or service, I need to use the API.
Yeah, because that's the only way you can get a static IP.
Oh, okay.
On the Atmosphere side, that IP is kind of at will. So we do maintenance on Atmosphere every 5 weeks. Now, usually all the instances stay running.
Okay.
However, if there comes a point where we have to take things down, the beauty about the cloud, we do maintenance all the time without ever taking anything down.
Okay.
Because all we do is, this blew my mind the first time around. I'm an old school Unix admin, so I'm used to dealing with a box or a cluster. And so our admin basically showed me you can evacuate a node. So say you have a VM running, you have a VM running, I have a VM running. They all happen to be on this node, and I need to take that node down to work on it. There's an OpenStack command that actually lets you migrate that live to another node. It basically takes it, clones it, moves it over, moves your networking over, moves you running on it,
Yeah,
without
that's-
you even noticing.
That's nice. For HPC, sometimes I need to wait for a week.
Yeah,
So if I want to run the week's job and they
Yeah.
are doing a maintenance the next
Yeah.
Wednesday, I need to wait maybe
Yep.
a couple of weeks. For
yeah, you
that.
don't ever have that problem with us for the
Yeah.
most part. The number of times we've had to take an entire cluster down for maintenance, we've done once. Now, we had a network outage that locked off everybody's access, but everything was still running.
Okay.
So,
Okay. So just to be clear, this is the network setting up is only for API.
right.
And if I do that, I don't need to use.
You don't need,
Yeah, okay.
Yeah.
And this is for more suitable for anything that you need.
yes.
A
This is-
networking.
Yeah, this is basically, yeah, if you just need an instance, you want to get to work on it.
Mhm.
This is best for classroom settings, for coursework. So I did a tutorial on this about a month ago on using Atmosphere. This was actually the follow-up to it. On Atmosphere, basically, you can customize your image, you save your image, and it's in the image catalog. And then anybody, you can set up the permission so anybody can run it or just you can run it. But basically, all of these images back here. So,
Okay, so that's nice. So if I'm, say, for example, if my students are running a simulation studies
Mhm.
and if he or she create an image, I can access anytime, right?
Yep.
Okay, and see how that's going.
Yeah, so
Okay.
so there are things in here like you can see. So here's somebody who has a Shiny server instance.
Okay.
So what they've done is they've taken one of our base images, they've installed Shiny server, everything they need on it, and then they saved it back to the catalog. Now anybody can use this, but they can use it again and again and again and again. So if they're running a class teaching Shiny server, he can just launch it, and he is teaching us. That's how I know about this one. Is he's teaching a class using
Okay.
Shiny server principles. So basically, his kids just come in and they each launch their own instance. They do their thing. It's beautiful.
So it just for for publication service, this API might be more suitable.
Yes,
right?
it
And
will be more suitable.
For research and computation purpose, I could just
Yep,
get things.
Absolutely.
Yeah. Okay.
absolutely. You've nailed it. Other questions? Anyone? No one? All right. Well, thank you all for coming today. That webpage with all the tutorial walkthrough is up. It will stay up. You all, I think I gave everybody my cards that have the Jetstream wiki and help address on it. Most answers to things can be found in the wiki. If you don't find something for some reason, shoot a message to help and we'll walk you through it. Without further ado, thank you all.
Okay. So you mentioned the startup account has 5,000 like
50,000.
50,000.
Yeah.
So
What do you guys think?
one unit is one core.
One core hour, yes.
1 core hour. Okay.
Yep. So you have 50,000 core hours by default.
Okay.
Yeah.
I think it might be something you can use for.
Are you planning another atmosphere tutorial?
I will probably be doing another one. I'm not sure. She's kind of the keeper of the schedule, so.
But it's possible.
Yes.
I
Oh,
see.
it's
So
and
you'll
it's
go
likely.
back and find out what they're doing.
Oh, I wanted to look up Ukraine
Sounds
for
like
you. I
right.
meant to
This
do
whole
that.
thing is kind of new for Dr. Helmicky to get back into doing this. So it's exciting.
That.
It's not our project, it might be exclusive for some other project.
Mhm.
Like people who not be in a position right now.
Well, and they'll be back. Maybe Jeremy will be back in a month or.
Well, that's what I was going to ask. She asked about another atmosphere tutorial,
Uh-huh.
and I was going to ask you.
Hopefully, if we can get something together in the
Okay.
next month or so, and I think.
So, do you put
Very
the
useful.
folks that attend on a mailing list, or
Mhm.
okay?
Yeah, I'll put you on a mailing list.
I'll be in Ukraine.
Ah, will you for the rest of the summer? Or?
Yeah, I'll
Yeah.
be back in August.
Yeah, so in the fall, definitely we'll have another.
Yeah,
we'll
I
have
think
another
definitely
series.
getting
Mhm.
getting a late summer, early fall would be perfect timing.
Yeah.
Come
Did you have a
on.
question you wanted to ask Jeremy?
We are thinking of how how expensive will it be? Do you have some kind of charges for using the services or something like that, or is it free?
It's free. So the only cost of it is that you write a proposal to use it.